So we go for question 24. Evaluate the following limit. So this is a concept involving limit at a point. For question B, this involving the concept limit at infinity. So every time we want to do our limit, our first extension is substitute first. Is it can get the answer. If we get IDF, then we find the way to simplify our function, then only we perform our limit again. So when you see we substitute here, 2 cubed will be 8, so 8 minus 8 is 0 already. At the same time, denominator here, 2 square times 2, 2, so it's also 0. So this is IDF form, indefinite form. So how to solve this IDF form, how to simplify it, we can see this is in the question of polynomial, so we can factorize it. So before we start factorizing, we can notice that we can use back our chapter 6 concept where this fraction, this polynomial, is in improper fraction. So for improper fraction, we can do our long division in order to simplify it. So we take out our cubic here, cubic x cubed, where x squared not exist, we put a 0. So x also not exist, we put a 0 minus 8. Going to divide. So purposely is want to simplify. Simplify our function so that we can get off from IDF form. So we do our long division for this polynomial. We take our x, multiply in to get x cubed. Then our balance here will be 2x squared plus 0x minus 8. Then we continue. We need a 2 here. We get 2x squared. Then minus 4x. And then our balance here, we will get 4x minus 8. So we cannot divide anymore. Because this is linear, this is quadratic, means our division will be stopped here. So after we simplify our improper fraction here, after we done our long division here, we can write our function into the form of quotient, where it is x plus 2, and then plus reminder 4x minus 8 over x squared minus 2x. So you can notice here, here we can factorize some more. So for this part, we can factorize out our value of 4, and we get a factor x minus 2. For denominator part, we can factorize our x, and also we get x minus 2. So we managed to simplify our function. So as long as we haven't do the substitution of the value, our limit notation it will be followed through for until we finish our simplified function here. So when we want to substitute, then only this limit notation no need to write. So we can try substitute our limit for x approaches 2 when 2 plus 2 plus 2, this is defined. For 4 divided by 2 also defined, so we can get our answer already. So it will be answer of 6. So look at here. This is our concept of simplify, and then approaches our value of limit x approaches 2, and get to the answer for this limit of a function where x approaches a point 2. For question B, when we have limit at infinity, so of course we will try to substitute our limit at infinity here. When I substitute infinity inside our function here, it will be infinity over infinity. So this is also in IDF form. So when we have IDF form, how we solve the limit at infinity, and we will going to divide the highest power of the denominator, but this is involving our cert. So we're going to look at our cert, what is inside our cert here. So inside our cert here, the highest power is x. The highest power is x. So we're going to divide every term of it by our highest power of x, square root of x. So for this question, when limit x approaches infinity, 5x plus 7 over 6x minus 5, we divide according to our cert. So our priority will go for cert. You can see our cert here. Inside our cert here, the highest power is x. So we're going to divide by cert x. So cert x, I can write it independently. Divide by x. And then divide by x. So every term we divide by x. And we try to simplify for this cert function. So you notice that this is 5 plus 7 over x. This is 6 minus 5 over x. So now we can solve this limit at infinity. When we substitute infinity into the part x here, 7 over infinity, it will be equals to 0. When 5 over infinity also equals to 0. So once we substitute our x infinity, our limit notation, it will be no need to write anymore. And when we value out what is the answer for this. So 7 over infinity 0, 0. So the answer will be square root of 5 over 6. So you can see here, when we have IDF in for a limit at a point and IDF limit at infinity, their solving method will be different.